David Smith here with one more flipped classroom math video for your enjoyment. 3 tips. First, you can speed up or slow down the playback if that helps you follow along. Second, you can pause anytime to catch up with your notes or think a little harder. Lastly, you could turn on the captions, which will show you my words on the screen below.
Psych! It's Michael instead of David. This is the modulus or absolute value function video with Michael. It looks like this. These big vertical lines are not ones, so sometimes it's better to make them even taller. And they mean modulus if you want to be British or IB, or absolute value for us on this side of the pond. How this works is the absolute value of a number is just equal to that number. Super easy, unless it's a negative. Absolute value of a negative just gets rid of the negative. You can think of it as the distance from 0. -8 is 8 away from 0. +7 is 7 away from 0. Pretty simple so far. Let's look at a graph. We're going to look at the graph of y equals absolute value of x. Whenever you need to make a graph, you can always make a table. There's even a button on your calculator that says table. Let's make a table. Oh, -7, -6. We're going to get bored really fast. Absolute value of -7. Pretty simple. Absolute value of 6. This is all, oh, that should be a negative. Let's make that a -2. Making a table can be kind of slow, but it always works, which is super nice. Then we go take our table to graph land. Remember that x is the horizontal, y is the vertical. You might notice that this part over here looks a lot like a good old-fashioned line, y equals x. X is 3, y is 3, slope of 1. Right? That part's really easy. Goes through 0, 0. That's that point. If you want to take a moment and pause and think about what equation this is, looks like, you could do that. If you've taken that pause, -1, 1, that's right here. -2, 2, right there. -7, 7, right there. What this part looks like is really y equals -x. So the whole graph is just a V. Put arrows on the end because it keeps going forever. There's your graph. Okay, we're going to do 2 more examples that are a little more interesting maybe, or more complicated. Here they are. This one is the absolute value, or the modulus of x divided by x. The other one we'll do is going to look like a quadratic with an absolute value on the outside. All right. These are more complicated, so your table tool might be your friend. Let's take a quick investigation here. Whenever you make a table, you almost always want to include x equals 0. It's kind of a key point of the graph. So nice to have that in there. And let's go look at -3. We plug that in. We're going to get -3 absolute value over -3. Notice the absolute value is going to make the top positive, but the bottom will remain negative. So we're going to get 3 over -3 for -1. You could pause the video, try the other ones if you felt like it. Welcome back from your pausing. Put in -1, all that changes is that and that. This is now +1, this is still -1. And the answer is still -1. Basically, this x is stripping the absolute value of x of its magnitude, but keeping the sign on the bottom. -1. If you put in 0, you're going to try and do 0 divided by 0. Hopefully, you remember our lesson on domain, and remember that this does not exist. Sometimes I write it as smiley face, frowny face. Can't solve it. 5, put that in. You're going to get 5 divided by 5 for just 1, 117, same thing. The graph of this is very strange. When x is positive, it's positive 1. When x is negative, it's negative 1. When x is 0, nobody knows, hence the hole at 0. Okay, hopefully you didn't hate that too much. Let's look at one more example. This thing I'm hoping you recognize as a quadratic that has been factored, and we're going to make it always positive. So here, instead of using a table, we're going to be even cleverer, perhaps. We're just going to graph as if the absolute value didn't exist first. We're going to graph y equals, hopefully that's on the screen, put it closer. We're going to graph y equals x minus 1 times x minus 5 in black, and then we're going to see what the absolute value will do. So hopefully remember that the roots are what makes this 0. So there's a root at 1 and a root at 5. Because it's positive, it's going to be facing upwards, happy quadratic. And it's going to look something like that. This point here will be when x is 0, so we could plug it in our brains, make a little table. Put 0 in, you get negative 1 times negative 5. Well, that's just positive 5. And then this point here is the vertex, super important. If you remember really all your things, it's the middle of the roots. So the vertex is going to happen at 1 plus 5 over 2 for when x is 3. When x is 3, we get 2 times negative 2 for negative 4. But we weren't trying to graph this quadratic, because that's old stuff. The new stuff is the quadratic that's been absolute valued. All you're going to do, leave all these positive things alone. They don't have to change. Take all these negative y's, like negative 4, and send it to positive 4. So it looks like that, with this fun little bounce and corner over there. Thanks for watching. Hopefully now you have an idea of what the modulus of the absolute value does to individual numbers and graphing it in some weird situations. Remember, you can always make a table and try and lean on your prior knowledge of what old things look like.
Alright, now that you've watched the video, take a minute and jot down any remaining questions so you can bring them to our next class. Also remember, you can watch the video again. Maybe that will deepen your understanding. If you like the video, please click like and subscribe.